Hello everyone. Today we would like to go through chapter 6 on logarithmic functions. So for today's lesson, we want to cover two objectives. The first one is simple manipulation of log expression using laws of logarithm, and also to understand how the conditions of logarithmic functions can be applied. So this is the question that we see in our end of the year exam papers, question 3. So in this question, it is given that ln x minus ln y is equals to ln x plus y. So the first part of the question requires us to express x in terms of x. Now, so to do this, what we will need is basically to apply laws of logarithm. All right, so over here, you will see a summary, all right, the 3 laws of logarithm. So as you can see from here, the 3 laws of logarithm is actually derived from this. Now, in part B of the question that require us to know a little bit more of logarithm is basically we will need to explain why the value of y is actually within 0 to 1. Now, in order for us to do this, what we need to know is we will need to know this condition. All right, so this is something very, very fundamental, which a lot of students actually overlooked and just did not pay attention to. All right, so in this case, what we need to pay attention to is for log function to be defined, there are 3 conditions. Basically, we need to know that a has to be greater than 0 and a cannot be 1. So a here we are referring to, which is the base of the log function. So the first 2 conditions for log to be defined, it has to do with the base, and the third condition has to do with the value of y. So the value of y, which is the log function, right? So whichever value that is within the log function itself, this value here, it has to be greater than 0. So with this, let's move on to solve the question. So over here, as I mentioned already, we will need to apply laws of logarithm, specifically is law 2. So if you can recall law 2, we have ln x minus ln y. So to apply ln 2, which is the quotient law, so what we will have is, this will give us ln x divided by y. Right-hand side, no change. So once we have this, what we will need to do is, we are going to apply method 1 of solving logarithmic equations. So in this case, we are talking about using equality of log. So by using equality of log, we will need to pay attention to that is both sides of the log function, they are exactly the same as in they have exactly the same base. So in this case, you will notice that both ln functions here, the base is e. So if they have the same base, then therefore I can conclude that the value within the log function, which is x over y on the left and x plus y on the right, they both has to be the same as well. So that is why it is called equality of log. So to apply this, then therefore I can conclude that x over y is equals to x plus y. So once we have that, we can simply just manipulate the algebraic expression. So over here, what we are doing is we are actually applying our algebra skill, that is changing of subject. So with this changing of subject, what we need to do is we will need to make x, all right, as a subject. So I multiply y to the right-hand side, and to make x as a subject, I just simply move the term together, the x together, and I just simply need to factorize out the x, and I am done. All right, so that is how I express x in terms of y. So part A is easily done by simply knowing the fact that I am able to apply equality of log, and we are done. Okay, so with this, we move on to part B. Now, so when it comes to part B, right now, we will need to state the range of values of x and to also explain clearly why the value of y is between 0 and 1. Now, as I mentioned earlier on, what we need over here is to know the conditions, all right, for y. So let's make some observation here. We see that ln x minus ln y is equals to ln x plus y. So earlier on, what we see is give me a while. So early on, what we see here is for log function to be defined, there must be some conditions to be met. So over here, you can see that if I want to state the range of values of x, so x is belong to ln here, so which means the value of x here itself, it has to be greater than 0. Yeah. So likewise for the value of y, all right, it has to be greater than 0 in order for the log function to be defined. So with that, I know that my range of values of x has to be greater than 0. Now, with this, then we move on. And what is x? So in part A, we have already derived that x makes x as a subject, as in x is already equals to y squared divided by 1 minus x. Now, with this, we can continue to deduce, since x has to be greater than 0, so therefore I know that y squared over 1 minus y has to be also greater than 0. Now, if you again make this observation, right, you will notice that y squared, this is a perfect square, and perfect square, we all know that perfect square has to be greater or equal to 0. But in this case, since my y has to be greater than 0, so therefore I can say that my y square value must be only strictly greater than 0. So with this, so in order for this whole function, y squared over 1 minus y to be greater than 0, and my y squared already greater than 0, then therefore I can deduce that the denominator 1 minus y must also be greater than 0. We solve the simple inequality, I will get y is actually less than 1. Now, earlier on, we also know y has to be greater than 0, isn't it? For ln y to be defined. So therefore, when I put these two together, combining y greater than 0 and also y less than 1, so combining these two, so therefore, we are able to conclude that the range of value of y has to be between 0 and 1. So with this, we conclude and explain why the value of y is within this given range. So hopefully this gives you a better understanding explanation.